Okay, so I'm going to record this portion, and then at the end I will, I'll also post this so anyone can see the examples that we'll talk about. Okay, so we've got 2 points. We've got, since the price is our input, our X value, let's see how this works. We've got $51 is the input value, 10,000 is the output. And then when we have 76 as our price, it drops by 1,000, so that would make it 9,000. Okay, so we can use this to determine the equation. What I like to do is just subtract the X and Y's. So 51 minus 76 will give us 25. Again, that'll be a negative 25. And then 10,000 minus 9,000 gives us 1,000. We take the input value, divided into, this is going to give us our slope. So 10,000 divided by negative 20 is going to be negative 50. So that is our slope. Y equals mx plus b. So y is equal to negative 50 times x plus b. And then we can take one of the one of the points. I'll take the 51, 10,000. So plug in 51, and 10,000 is the y value. That will give us our y-intercept. So this is 10,000. This is negative, where's my calculator? Just want to make sure I get it right. 50 times 51. I thought that would be right. 2,550 plus b. So then we add 2,550 to both sides. And we get that b is equal to 12,550. So that's going to give us the equation here. Type that in. The equation will be, instead of y, we're going to use q. And what did we come up with? Our slope was minus 50. P plus 12,550. Okay. And then again, P is the cost of the book. So as the, looks like as the cost goes up, the demand goes down. Okay, now estimate the unit price that maximizes annual revenue. So annual revenue, this is looking at so what we're going to do is set up the elasticity. We're going to find where the elasticity equals 1, and then we'll be able to get the equation. If anyone sees any errors that I make along the way, please jump in. Let me just make check my arithmetic here. Okay, good. And then 1,000. divided by, oh, it's 25. I caught it on my own. Okay, so let's back up here. This is not 20. Right one, oh, there we go. This should be, and this is not going to be 50. This here is 25. So 1,000 divided by 25 is negative 40. So now, this is, again, a very important part of this. Well, it's not being very cooperative, so we'll cross this out. This is going to be 40. 40. And so 40 times 51 is 2040. $2,040. So our equation see why it's doing what it's doing, is going to be minus 40x plus 1240. Is that looking better? Hopefully we're all hearing it. Okay. So let me clear this off. So what we want for elasticity equals minus starting this. So the derivative of the demand function times P over the demand function. So we're looking at this function here. The derivative is going to be negative 40. Multiplied times P from the formula divided by the equation from the formula, which is minus 40P plus 12,040. So we get the equation of minus 40P all over minus 40P plus 1240. What we want to do is we want to find where that is equal to 1. Are we okay so far? Anyone can chime in?
Yes.
Okay, good, thank you. Okay, so think of this 1 as 1 over 1. We're equal to a fraction, so we can cross multiply. And basically that gets us that the denominator is equal to the let's see. Cross multiply, we get negative 40 p. Oh, one more error. The elasticity for demand has a negative in front, right? Negative, the derivative. So this negative 40 is the derivative. We have a minus 40, which makes it a positive. And I just noticed that because as we come over here, if I don't do that, the variable wipes out and our price is going to be 12,000, which is quite a price for a book. Okay. Okay, so we cross multiplied, we get the two equal. We want to solve for p, so we add 40p to both sides. And we get 80p equals 12,040. Divide both sides by 80. That will give us P is equal to 1240 divided by 80. Gives us $150.50. It's supposed to maximize the profit. And then what we're going to do is find out what profit we would be able to achieve. So we put that back in here. Let's just do a quick check. So elasticity should be equal to 1. I'm going to So, okay, what is the price? What's the actual revenue? The revenue, remember, is going to be the price times the quantity sold. Okay, so we've got the price is 150.50. Quantity sold is going to come from our equation up here. So that's going to be minus 40 times the price of 150 plus 1240. Okay, so let's see what kind of amount that gives us. So negative 40 times 1 50.5 gets us in here, negative 6,020. $12,040. So we come up with 150.50 times 6,020. This will sell 6,020 books at a price of $150.50. Come up with a value, I ran out of space because it wasn't writing up here, of $906,010. Almost $1 million. Let me do that one more time. 150.5 times 6,020. That's what I get. So let's go ahead and enter it. And then we're going to submit it. Hopefully it's correct, because when I made a few errors along the way. No, I didn't like it. Okay. And the equation itself wasn't correct, so we probably should have checked there. The process, though, is correct once we have the linear equation. Did anyone spot where I went wrong on the linear equation? Okay. The sales amount to 10,000 per year. Price is $76 a book. The sales drop to, oh, it drops to 1,000. Okay. That's where I made my error. I thought it dropped by 1,000. Okay. A very big difference. Okay, so we've got two different points from the start, and I apologize. I just sometimes working the technology, I'm concentrating on that more. So 2 points we start with is $51 per book. We'll sell 10,000 books. $76 per book. We sell only 1,000 books. So when we subtract these two, we end up with negative 25, which is fine, and 9,000. Take 9,000 divided by negative 25, and we get negative 360 as our slope. Very different equation. So now, thinking of a linear equation, y equals negative 360 x plus b. Plug in the 51 for x, the 10,000 for y. $360 times 51 gives us negative 18,360 plus B. And then we're going to add that to both sides. So that gives us 28,360 as our y-intercept. So putting that together, we find that Q, which is the y value, is equal to negative 360 P plus 28,360. So what I'm going to do first is, before I go through and solve the rest, which, let's see, that probably didn't help either, but negative 360 P plus 28,360. Take this part out now. Let's just check on the equation, just to make sure we got that part right. There we go. Okay, so read the question carefully and correctly. So now we've got a correct equation. We follow through with the same process that we did last solution with the wrong equation. So I'm going to clear off this work, and we'll, again, look at elasticity. It's equal to minus the derivative of the demand function times P over the demand function. The derivative is going to be negative 360, so that's a minus negative 360. Times P over negative 360P plus 28,360. So our elasticity function, negative makes that a positive, times P, so we get a positive 360P over minus 360P plus 28,360. There we go. And again, of course, we want all of this to be equal to 1, so I'll just replace the E with a 1. Because that gives us our maximum revenue. We cross multiply, so cross multiplying gives us 360P equals negative 360P plus 28,360. We add 360P to both sides. That gives us 720 P, which is equal to 28,360. Zero here somehow. And so now we divide both sides by 720. We find that P is equal to 28,360 divided by 720 come up with, really? $39.39. 28,360, 28,360, 28,360. Okay. And again, feel free to voice in if you see anything. Oops. 39. That just doesn't feel quite right because of the values they gave us. So I'm going to check that before we move to the, okay, it's correct. It just feels, doesn't, $51 for 10,000. So by bringing the price down, we're actually going to sell enough extra that we'll get the best revenue by going for this price. And then, so now to get the revenue, these are pretty involved problems, aren't they? The revenue is going to be price times quantity. So that's revenue. The price is $39.39. The quantity, we use the formula, minus 360 times $39.39. And then we add the 28,360. And we do this calculation. 360 times 39.39 gives us minus $14,180.40. Add to that the 28,360. And that gives us 14,179.60. And finally, multiply that by the price. So it means we'll sell about 14,179 books. And a price of $39.39. You still make a good profit here, or it's not profit, a revenue. $558,534.44 is what I come up with. And let's check that one. 558,534.44. And we got it. So apologize for that. That took us most of the class time to get through one problem, but all of these will be the same. You'll be using this this elasticity function for the price demand is what we're going to focus on, not the income. So if you had issues with the income demand, we won't be doing problems on those. So that'll be okay.
Professor, I just have a quick question.
Yes.
For the first couple ones, the formula provided is like Q equals the numbers, but the formula for elasticity is derivative of F of P times p over the f of p. So would we use the formula q of this?
Yes, that formula that they're giving you, that's your think of that as your f of p. So that's the function that you use. You'll take its derivative, and that's the first part of the elasticity function, and then you'll take p divided by that equation that they give you, or that formula.
Okay.
Does that make sense?
Thank you.
Okay, you're welcome. Yeah, it looks like first one's linear. The second one is a quadratic, so that'll add a little bit of, and the second one's quadratic as far as, the third one is also a quadratic formula. Actually, I stopped sharing the screen. Let me go back. So yeah, you'll see this first function here is, just think of this. This q is really your f of p. So think of it, it's what you'll use is again, each of you will probably have different ones for different parts. But the q that they're giving you, think of that as f of p. And then again, you'll take its derivative, and that's part of the form to put it in the formula here. Okay, anything else at this point?
Professor, maybe we can take a look at 12.5, number 8 or 9.
8 or 9. Okay, so let me clear this out.
5. Thank you.
You're welcome. 12.5. Was either 8 or 9?
Yeah, any of those.
Okay, let's start with 8. It's a little bit more straightforward. 9 is similar, but we've got to take the derivative of the natural log. So let's go ahead and take a look at 8. Okay, so on this one, and let me remember what 12.5 was, implicit differentiation, right? To come up with the rates, related rates. If I'm okay, so what we've got is we've got an equation that's given. We're given a graph y equals 1 over x. Since we're going to be taking derivatives, I'm going to rewrite this as y equals x to the minus 1. Just makes it easier to take the derivative. It's moving along a curve in such a way that its x-coordinate is increasing at the rate of 6 units. So what that tells us is, remember, everything we're taking in terms of time. So the derivative of x with respect to time, it's telling us, is equal to 6 units per second. What is happening to the y-coordinate at the instant the y-coordinate is equal to 7? So what is happening to the y-coordinate? So what the question's really saying is, what is dy dt? So how fast is this changing when y equals 7? Okay, so what we do first is we use implicit differentiation we've got two variables here with a sort of the hidden variable of t. So when we take this derivative, the derivative of y is, I want to think of it as really it's 1 dy dt. The derivative of x is going to be the negative comes down, -1. Subtract 1 from the exponent, so that's x to the -2. And this is going to be the derivative of x with respect to t. Okay. And now what we can do is we can plug in our, so dx dt we know is 6. The problem is we don't know what x is right now. So what we're going to do is we're taking the information we're given that when y is 7, we're actually able to plug this in to either one of these equations, plug y as 7 and figure out what x is. Then once we have that value, we'll put that value in here and we'll know what's happening to y at that point. Okay, does that make sense? So over here, we'll say that 7 is equal to x to the -1. And again, mathematically, it might be easier to solve with thinking of x to the -1 as 1 over x. Think of 7 as 7 over 1. Cross multiply, you get 7x equals 1. Divide both sides by 7. So you get x equals 1/7. Okay, so that's what we're going to plug in for this x up here. So what we get is that dy dt is equal to -1 times 1/7 to the -2. dx dt is 6, all times 6. So we just need to do this arithmetic here. Dy dt, -1, 1 over 7 to the -2 is going to be, invert this, that becomes 7 to the +2, that's 49. Right? Negative exponent means reciprocal. Reciprocal of 1/7 is 7. 7 squared is 49. And so what's happening to dy dt is we've got -1, 49 times 6 is 294. That's way out there. 294 units. So what we can say is that x is changing by 6 units, but what's happening to the y coordinate? It's decreasing because it's negative at a rate of 294. 294 units per second. Does that make sense? It seems a little high, but let's, because it is this inverse relationship. Where are we? Number 8. Hey, we got it right. Okay. Was that helpful?
Yes, thank you.
Okay. Let's see how much time. We got about 15 more minutes. What else would you like to see? Come back to the chat. Number 9. Okay, got a request for number 9. I was afraid of that. No, I'm not really afraid of that, but we will, yeah, we will take a look at number 9. Actually, I got a request. It's hard to watch everything. 7, 9. Let me take a look at what 7 is. That's 3. Yeah, either one of these is going to, so this one has a negative exponent, which we just sort of went through. But now looking at this, I see number 7 was asked first. So let's go through number 7, and then we'll take a look at number 9, because we can extend this. That's the nice thing, is nobody else is going to come into this room. So let's take a look at number 7. And let's see, how do I get this out of here? There we go. Okay, number 7. Okay. And thank you all for your patience. It's sometimes you just have to jump in and start doing things and see how things work. Okay, so we've got this average cost function. We could think of this as y equals this formula here, this equation. X is the number of CD players manufactured in a week. Weekly production is currently 4,000 players. So we've got currently at X equals 4,000. Wait, weekly production is currently 4,000 players and increasing at a rate of 400 players per week. So dx dt, the rate of change of X, is 400. What is happening to the average cost? So think of the average cost as like we could just think of it as Y, if you'd like. So sometimes it's easier to just think of the formula. This is our average cost that we're looking for. 160,000 X to the minus 1 plus 10 plus 0.123 X. Okay. So we want to find, okay, the derivative of both of these. So we're going to take the derivative of y, which is dy dt. We want 1 dy dt. We take the derivative of x, and every time we do that, we get a dx dt, remember? So we take this derivative, and that's going to give us negative 160,000 x to the minus 2. Derivative of 10 is 0. And the derivative of this last part, oops, sorry. I forgot I hadn't really finished this. It's this. Since we took the derivative of x, and we've really got 3 variables here, this gives us a dx dt. This is 0. The derivative of this is going to be 0.006 dx dt.
I think there's 3 zeros.
There's 3 zeros. There are. Thank you. Okay. One more 0. There we go. Okay. So what we need to do, just like the last one, since we've got an x in this formula, what we need to do is, this is easier. We don't have to solve for y. We know that x at this point is 4,000. So we're going to plug that in for this x. Everywhere we see a dx dt, we're going to plug in 400. So this one's not quite as bad as the last one. So we've got dy dt is going to be negative 160,000 times 4,000 to the negative 2 times the xdt, which is 400, plus, and again, we'll get our 3 zeros here. Actually, I got to get my glasses updated. My bifocals are not doing so good, and on the for this type of work, having good bifocals is going to be valuable. Okay. 0.006 dx dt is 400. So it's a matter of just carrying out this whole calculation. Think of this as 4,000 squared, right, underneath. I think that's going to give us about the 16, see, 4,000 times 4,000 is, oh, that's 16 million. Did I do that right? It is. Yeah, we get 60,000 in the top times 400 divided by 16 million in the bottom. Let's go ahead and do this, 0.0006 times 400. That's going to give us 0.24. Just need to carry this out. 160,000 times 400. Negative 64 million. These are nice at this point. All over 16 million. That's just going to be negative 4, right? Just to be sure. So yes, this is negative 4. It's 0.24. So when you add those together, we get negative 3.76. I don't know why this does it at this point, but let's plug that in and see if that works. So it's negative, so we know it is decreasing. And it's decreasing at what is the average cost of $3.76 per player per week. I guess so. It worked out. I'm always, after doing all that kind of work, it's always nice to have it work out. Any questions on that? And thanks for the catching those 3 zeros. That would have really been a terrible mistake. Okay, we have just a little bit more time, so let me do question number 9, since that was requested as well. And then Friday's meeting, there won't be another lecture to take a look at. Thank you guys for keeping on top of things, but we'll have another opportunity Friday to answer questions and do this, and I'll do a little bit more practice and hopefully get a little bit better, a little bit at a time, right? Don't have too big of expectations, but always keep putting in the effort to do the best you can do. And then do better than what your best is, because we always have it. Okay, so let me check here. if there is any. No more chats have come up. Okay, so I'm going to do number 9. Again, you guys are always welcome to leave at any time or hang out. This is being recorded, so I will post this, and just remember to fast forward through that first problem until I get to the place where I did okay. Okay, so in the 1990s, the demand for personal computers in the home went up with household income. Oh, so there is one income problem. I should. For a given community in the 1990s, the average number of computers in a home could be approximated by this equation. Are we in the right place? This is feeling. What section are we on? This is 12.5. Okay, 12.5. For X is a mean income, a certain community had a mean income of 25,000, increasing at a rate of 33,500 per year. How many computers per household were there? Okay. And then how fast was the number of computers in a home increasing? So it's getting me confused because it's kind of like the next problem set, but it is a little different. So what we have is Q is the number of computers, X is the income. And what we are told that the mean income for a certain community, so their X, X at a particular point is 25,000, with the rate, the income changing, so dx dt being equal to a positive 3,500. We're given this formula where quantity equals 0.3452 natural log of x minus 3.048. Okay. And we are in the domain because our x value is at 25,000, so this is only works between 10,000 to 125. So what we want to do is we want to take the derivative of everything, and remember there's this third variable of time, so when we take the derivative of q, we get dq dt. We take the derivative of this side, so we get the derivative of natural log, remember, is 1 over x. So what we're going to get is 0.3452, because that's a constant, over x times dx dt. Again, implicit differentiation. This last part drops off because that's 0 when we take its derivative. So far, nice and clean. I guess I could have answered the first question without doing this. So the first question really is just plug in 25,000 into x, right? Where x is around here. How many computers per household were there at that time when there was 25,000? So we could answer that, plug in 25,000, and we'll get our answer. But for this one, what we have to do is we plug in the 25,000 for x here, but we also plug in the 3,500. So to get the change, dq dt, that's 0.3452 divided by 25,000 times 3,500. So dq dt. Let's do the math part. And I'll do an on-screen calculator because a lot of times that helps. You'll be able to catch when I make calculations. But 0.3452 divided by 25,000, that gives us 0.0001381 times 3,500. So I get 0.048. How fast was the number of computers in the home increasing to 4 decimal places? That doesn't make a lot of sense, but 3, it's 2 8, so the 2 gets rounded up to 3. And now before I put my answer in, I'm going to come over here and we're going to figure out how many computers there were in the house. No, not there. Sorry, we're going to come from here. So the number of computers in a house is equal to 0.3452 times the natural log of 25,000. Still got a few of you. Of course, if you all leave, I'm still going to keep going through this because it's being recorded. And I know you may have other classes you need to get to. And even though we're not physically on campus, you may have other appointments. So that's fine. Minus 3.048. Okay, let's, oh, wait. This is a multiply. Sometimes the hardest part of math isn't the hard stuff, it's the making sure you write everything down correctly. So let's turn the calculator sideways. So I have a natural log. Let's clear out. I'm going to take the natural log of 25,000 natural log. I get 10.1266. I'm going to multiply that times 0.3452. And for that, I get 3.4957. So I'm going to go out 4 decimal places minus 3.048. So what we get is that the number of computers per household, it's about half a computer per household, less than half a computer. So not every household has a computer is what we're saying. About every 2 households, actually a little bit more than 2. Let's see if it all works out though. Should be pretty straightforward unless I made a calculation error, which always possible. 0.4477. That's how many computers there are in a household. Again, just taking the formula I get, plug in the 25,000, do the calculation. To get how they're changing, we take the implicit derivative. So we get a dx dt, which was 3,500. Okay, so that's looking good. We plug in the 25,000 here. I think we're okay. And so now we're increasing at 0.04833 computers per household. It's going to take a while before it makes much of an impact, but let's see if that all worked. I hope so. Good. It's all correct. So I'll take a break at this point because I don't know that I'll be much good to you. I'm going to unpack the video and then I'll post it along with the lecture video. And then Friday we will have class time available to us just to meet and answer more questions. Does that sound good to everyone?
Yes, thank you very much.
Thank you.
Thank you so much. This was very helpful.
Well, thank you so much too. It's I'm glad you're here. It would have been very boring without y'all. Okay. Take care, y'all, and we'll
Have a
see you
good day.
Friday. Okay, you too. Bye-bye.
Bye.